Hello, welcome to helpyourmath.com.
Welcome to part 2 of exponents. In this part, we're going to discuss the quotient rule. The quotient rule says that when we keep the bases the same, meaning that they have the same bases, we subtract the exponents. So, for example, if we have x to the m and x to the n, that means that x to the m is divided by x to the n, and that means we're going to subtract the exponents of x. Notice how the base of both of these is the same, and it's x. So, for example, the reason we can do this, so if we have 2 to the 6th power divided by 2 to the 3, so I have 6th power means 2 times 2 times 2 times 2 times 2 times 2, and 2 to the 3rd is 2 times 2 times 2, and then I can cancel out 3 of these 2 from the top, 3 from the bottom, and I put this 1 in here as a placeholder. And that means that I have 2 times 2 times 2, or 2 cubed, and this is essentially 1 because they're exactly the same. So that's the same thing as saying 6 minus 3, which is also 2 cubed. And it just turns out that if we work that out, 2 cubed is 8. And so here's just another example where we're using the variables instead of the 2's, and the same idea, as one can see, that in the end, instead of getting 2 cubed, you get x cubed. So when you divide powers, you subtract exponents. So let's look at some examples. In example number 14, we have x to the 15th over x to the 10th. And if you notice, our bases are the same, so that means, which is x, so that means we can subtract 15 minus 10, and that will give us x to the 5th. In example number 15, we have w to the 27th over w to the 9th. So that means we just subtract 27, the exponents, 27 minus 9, in order to get w to the 18th. For number 16, we have a to the 9th over a to the 9th. Well, it turns out that 9 minus 9 gives us 0, so that's a to the 0. And if you haven't learned this, this is a very important thing to know, that any expression to the 0 power is always equal to 1. So this is a very important thing to know, and that's something that will occur over and over and over again. In number 17, well, we have a to the 7th, b to the 4th, a to the 7th, b to the b squared. Now let's go to the whiteboard and work this out in greater detail. In number 17, we have a to the 7th, b to the 4th, over a to the 7th, b squared. So as usual, I'll put my a's in one bracket, a to the 7th, a to the 7th. And I'll put my b's in another bracket, b to the 4th, b squared. And then I will use my quotient rule. So I have, for the first one, a to the 7 minus 7. And then for my b's, I have b to the 4th minus 2. Now it turns out a to the 7 minus 7 is a to the 0.
and b to the 4 minus 2 is b squared. And it turns out anything to a 0 power is equal to 1. So our a to the 0 is equal to 1, and then b squared. But we usually don't write the 1, just like when we have a silent E or something like that. We may write it, but we don't say it. But in this case, we see that it's there, and we know that that 1 is there, but we usually just write b squared.
So in reviewing what we just did on the whiteboard, for example, number 17, we see that we collect the A's, and 7 minus 7 is 0, and the B's, 4 minus 2 is 2. And as we said, anything to the 0 power is 1. So that gives us 1 times b squared. So that means it's just b squared. So remember, any expression raised to the 0 power is equal to 1. And this will come up many times and very often, so it's very important you understand this concept. When dividing a monomial by a monomial, we must first determine the sign, divide the coefficients, and divide the letters by subtracting the exponents for like bases. So why don't we do a few examples to understand what this means. So in example number 18, we have negative 24 times x to the 6th y to the 5th divided by negative 6 x to the 4th y squared. So why don't I go over to the whiteboard and work this out in detail first.
In example number 18, we have negative 24 x to the 6th y to the 5th divided by or over 6x to the 4th y squared. Now, as before, we'll put our numbers in one bracket, negative 24, negative 6, and we'll put our x's in another bracket, x to the 6th, x to the 4th. Then we'll put our y's in a final bracket, y to the 5th, y squared. Then we'll work out each of them separately as we've done before. We know a negative over a negative is a positive, and 6 goes into 24 4 times. Now we have the next part here. So we have the x's. So it's going to be, based on the quotient rule, 6 minus 4. And then we have y, 5 minus 2. And now we can finish it up. 4, x, 6 minus 4 is 2. And 5 minus 2 is 3, so that's going to be y to the 3rd. And that's our final answer.
In reviewing what we just did in example number 18 on the whiteboard, what I did was, just like I did on the whiteboard, I gathered up my coefficients, my x's and my y's, and worked out each one individually. So I got 4x 6 minus 4, because that's a quotient, using the quotient rule. Here, using the quotient rule again. And I have 4x squared y cubed, and I just write that for x squared y cubed. In example number 19, we have negative 35 c to the 18th d to the 12th divided by 5 c to the 10th d to the 7th. So here, let's work this out on the whiteboard in detail first.
In example number 19, we have negative 35c to the 18th, d to the 12th, divided by 5c to the 10th, d to the 7th. And as before, I'm going to put my numbers in one bracket and work that out. And then I'll put my c's in the next bracket. And then I'll put my d's in the last bracket. And then I'll work it out. So my first one here, I have negative 35 over positive 5. So 5 goes into negative 35. Well, a negative over a positive means it's negative. So we get negative 7 here. And then for the next part, we get C, 18, using our quotient rule, minus 10. And then we get D, 12, minus 7. And then we continue to get negative 7. 18 minus 10 gives us C8. And then 12 minus 7 will give us D to the 5th. And that's our final answer.
In summarizing example number 19 that we just did on the whiteboard, as usual, I gather together the coefficients and the like bases with the like bases, and then I go through here just the regular division, and here the quotient rule and applying the quotient rule. So I get finally negative 7c to the 8th, d to the 5th. In example number 20, we have negative 100x to the 14th, y to the 20th, z to the 30th, divided by negative 20x to the 7th, y to the 10th, z to the 15th. So now again, let's go over to the whiteboard and work this out in detail.
In example number 20, I have negative 100 x to the 14, y to the 20, z to the 30, over negative 20, x to the 7th, y to the 10th, z to the 15th. And as usual, I'm going to organize it in brackets. In my numbers, I put in one bracket. And then I'll put my x's in the next bracket. I'll put my y's in the next bracket. And finally, my z's in the last bracket, 13. And there I have that. And I will do my division here. Well, a negative and a negative over a negative is a positive. And 20 goes into 100 5 times. Then I will use my quotient rule. X to the 14 minus 7 And then for my y's, y to the 20 minus 15. I mean 10. And then z to the 30 minus 15. Be careful there. That is to the 10. And then I get 5 x, well, 14 minus 7 is 7. And then I get 20 minus 10 is 10. And then I get 30 minus 15. And there we have z to the 15 power. And I just write it 5x to the 7, y to the 10th, z to the 15th, and that's my final answer.
Summarizing example number 20. As before, I collected up the coefficients, my x's, my y's, and my z's, and worked each one out separately to get my final answer. 5x to the 7th, y to the 10th, z to the 15th, just like I did on the whiteboard. In example number 21, we're asked to simplify negative 5x cubed, y to the 4th, times 4x squared, y, and all this divided by 10x to the 4th, y squared. So let's work this out on the whiteboard in detail to see how it is done.
In example number 21, I have 3 sets of monomials, negative 5x cubed, y to the 4th, and that's multiplied by 4x squared, y, and then we divide that by one more monomial, 10x to the 4th, y squared. I'll put that in brackets. So 1, 2, 3 monomials here. But we go about this the same way because here we have, probably we'll have to use the product rule and the quotient rule to complete this one. So again, I'll put together a bracket with all my numbers in it. So I have negative 5 times 4 divided by 10. And then I'll take all my x's. I have an x here, I have an x here, and bottom there. So an x cubed times x squared, and then it's divided by x to the 4th. Then I'll do my y's. I have a y to the 4th here. I have a y here, and I have a y squared here. And here I'll do my multiplication on top. So negative 5 times positive 4 is negative 20 divided by 10. So I'll do my product rules first. So I have x3, 2. So I add those up. So that means I get x to the 5th over x to the 4th. And I have 4 plus 1. So I'll have y to the 5th over y squared. Now I'll use my, I know negative 10 divided by positive, negative 20 divided by positive 10 will give me negative 2. And then for this one, I use my quotient rule. 5 minus 4 will give me just x. And then 5 minus 2, and that will give me y to the third. And that's my final answer.
In reviewing what we just did on the whiteboard, we see that we get putting together all the coefficients, negative 2, and then we put the x's in the next bracket, the y's in the y bracket, and work each one of these out separately till we finally get negative 2xy cubed. Thank you very much. I hope that you enjoyed this video and that it helped you understand exponents a little bit better. Take care, be well, bye.